Hello and welcome to this SPHN tutorial, which will present how the SPHN RDF schema can be expanded to answer the needs of a project. In this tutorial, we will first present the ontology editor Protégé that will be used for editing the project ontology. Then we will introduce the SPHN strategy for projects before highlighting the steps that need to be followed to extend the SPHN ontology with a concrete example, the fluid balance. And finally, we will have a short summary. The tool Protégé is a desktop ontology editor meant to be used for building and editing ontologies. It is accessible and downloadable through this link. Protégé supports the World Wide Web Consortium standards, meaning that any RDF content can be loaded and edited in Protégé. There is also a web version available called Web Protégé, which enables, in addition, a collaborative development of the ontologies, but it should be noted that Web Protégé does not support all features provided by the desktop Protégé. In SPHN, the Data Coordination Center, or DCC, recommends and uses Protégé for building and editing the SPHN ontology. There is also a web version of the ontologies developed accessible at webprotege.dcc.sib.swiss. The SPHN has a specific strategy for projects to handle the SPHN ontology. It actually enables the projects to extend the SPHN ontology to fit their needs. To enable this flexibility, there is, however, the need to define rules that must be followed by the projects to ensure that data fairness can still be achieved in the context of that project. Therefore, an SPHN documentation has been developed to present these steps, accessible through the Read the Docs framework, and in this tutorial we will be going through these different steps. So first, let's start by loading the template ontology in Protégé. So what is the template ontology? It is a turtle file provided by the DCC to help the projects to start with generating their own project ontology based on the SPHN one. This template actually contains the SPHN RDF ontology imported. It also imports external libraries that are used in the context of SPHN, like RDFS, OWL, and others. And it also contains prefixes already defined and some pre-filled metadata that needs to be updated by the project. The template of ontology is available at the DCC's Git. And there are two requirements before loading the template ontology into Protégé and follow this tutorial. First, make sure that you have the test project repository loaded in your computer, which is provided in the training material, the repository. And then second, make sure to increase the heap space of Protégé if needed, so that you are able to load the external terminologies that are used in SPHN and which can be of a large size. And for that, you have a tutorial provided by the Protégé wiki. With that, we now switch to the Protégé tool and start our demo. So this is how the interface of Protégé looks like when you open it. And we will simply start by loading our template ontology. So we go to File on the top left, click on Open, and then you have a new pop-up window that appears. And I am already in the test project repository, as you can see. So make sure that you go into this repository where you will have the different files that we do provide. So there are external terminologies. There is a catalog file that will be read by Protégé to load the external terminologies and, as you can see below, the SPHN ontology. And what we are interested in now is to open the template ontology. So simply select the template ontology and click on Open. Now you can see that the files are being loaded into the system, into Protégé. And once it is done, a new window appears with all the information contained in this template ontology. On the left side, you have information about the ontology, which contains ontology IRIs, version IRIs, as well as some annotations. On the right side, you have some ontology metrics that gives you information about the content of this file. And at the bottom, you have other information such as the imported ontologies into this project or prefixes that are defined and other axioms. In this case, you can see that the ontology IRI has a generic name that we called project name. And the first step for us now would be to update this ontology IRI and the version IRI. So simply select the project name with your mouse or simply with your keyboard, delete this text and add the name of your project. For the sake of this tutorial, we call our project test, but it can be any other name. So we simply write in place of project name test, which will represent the ontology IRI for this project. Similarly, I go to the ontology version IRI and change the project name with the same name that I gave for the ontology IRI. So here, test. Then go to the year, select the year, and make sure to change it to the year where you are developing, in which you're developing this ontology or this project ontology. Here we are in 2021, so my test project ontology is being developed in 2021, and the version here is the first version that I'm generating for this ontology in 2021, so therefore I just simply type 1. Once this is done, we have to also update the annotations. You can see that we have this generic project name that has been given for the title and the description of this ontology. And in order to edit this, you simply go onto the right side where you have a button that you can click on and that tells you that you can edit this annotation. When you click on it, you can see that there is the DC title selected, there is the project name ontology text, and we will simply edit the text project name to put the actual name of our project. Here, again, it is test ontology. Once this is done, click on OK, and you will see that the title of your ontology has been updated. Do the same thing with the description. The description says it is the RDF schema describing concepts defined in the test dataset in this case. For you, again, this will be the same name as your project name. Click OK, and now you have updated the metadata that we have provided to this ontology. Okay, so the next step now is to go to the ontology prefix tab. So click on this tab and you would see already a list of defined prefixes with their values. And the first step to do here is to take the base prefix, which is defined on the first line, and update its value to reflect the IRI of the project ontology. So simply double click on the value here, select the project name, remove it, and as you did for the ontology IRI and the version IRI, add the name of your project ontology. Then you should not forget, and you must add either a hash or a slash at the end of this value to ensure that any content that will be added in your data later on next to this namespace or after this namespace will be considered either as a class or as a property or any other information coming from your ontology. So make sure to add this hash or the slash. It doesn't matter which one you use. Here we use the hash because we used the hash for the SPHN ontology and we want to be consistent. So simply click enter or type enter when you're done. And the second step to do here is to add the specific prefix for your ontology. So you see that for the SPHN we have a specific prefix defined, and we would like, or we recommend to also have your project prefix defined and not only as a base one. So simply click on this button here on the top left, add prefix mapping, you see that a line has been added now with the prefix P0. Double click on this prefix, remove it, and simply add the name of your project. So here we say test, type enter. Then I suggest that you can simply copy the base prefix value and paste it under your specific project prefix. Here the test prefix. And type enter, and you're done with annotating the metadata of your ontology. With that, you can now save this file as your specific project ontology. In order to save a file in Protégé, you need to go through File, Save As, so do not mistake and don't go for the save, simply go to Save As. Protégé will ask you to select a format in which you would like to save your file. You can observe that there are several file formats that are available. We recommend to at least save your ontology in a turtle syntax and in OWL XML syntax so that you can load it in the different tools that we are using in the context of SPHN. So we select here turtle, click OK, and we need to type in the file name. We call it here the test ontology. It's a turtle file, so .ttl. And you can see that we actually already provided a test ontology in the materials, which already had those metadata updated or integrated. So simply click on save once you have your file name, and this file will be saved as a turtle in your computer. So from now on, anything that you will add in the ontology, you can simply just save or do Control S to save your changes. Okay, so now we are interested in this tab called Entities, and we will simply go through it. You see that there is a change of view in the Protégé tool because now we have entered into the aspect where you have all the information from the ontologies that will be depicted. So you have the classes, you have the object properties, the data properties, and so on. Let's switch back to the classes here and expand this OWL thing. And you see that we have the SPHN concepts that are defined here. If I expand it further, I have all the content from the SPHN ontology. This is appearing because we have imported the SPHN ontology in our project. Now what we need to do is for each of these elements, so mainly the classes and the properties, we need to add a root class or element, as like the SPHN has done, which will hold all the metadata or information that we want to see in our project-specific ontology. So in order to do so, I can either select OWL thing and add a subclass to it by clicking to this button, or I can also select the SPHN concept class and add a sibling class to it. So there are two options here. Let's just go with the sibling option. So I am selecting the SPHN concept, and it would add a sibling class next to it. This class will be named after our ontology. So I call it test concept. The convention in SPHN is to use upper camel case for creating classes. And you can see below the name that there is the IRI depicted, and the IRI is the IRI that we specified in the active ontology tab previously in the ontology IRI. So everything is correct now. We simply click OK once we have added the name, and you can see on this right part of the Protégé tool that you have your concept or your class, and next to it you have the actual IRI of what is this unique identifier of the class. The next step to do is whenever a class or a property has been added, we recommend to add at least a label and a comment to it or a description to it. You can see an example here in the SPHN concepts where we already have the RDFS label and RDFS comments that have been added to the description or of the SPHN class, concept class. Let's do the same with the test concept class. So in order to add an annotation, simply click on the plus sign next to annotation, select the type of annotation you would like to add from this list. Let's say we want to start with the label. I simply add a human readable label. Here it is test concept with a space. Click OK, and you can see that a label has been added to your test concept class. Next thing to do is to add the comment, RDFS comment, which would be a description of what this class is about. I already have some text written on the side, and I'm just copy pasting it, saying that this test concept class is basically containing concepts defined by the test dataset. So once you have done it, you can simply click OK or type enter, and you would see that you have annotated your class test concept. So this test concept will hold all the classes defined in the test ontology. We now do the same thing with the object properties. So if you again expand this root element, you would see all the object properties defined in the SPHN ontology. And now we want to add a new root property for object properties for our specific test ontology. So we call this root node test attribute object, again with an upper camel case convention here. And you see that the IRI is also updated accordingly. Simply click OK, and now you see the test attribute object has been created as a property, and the IRI is also visualized here. Then you can add the annotations to it, so a label first, which will be the test attribute object. Again, I'm following the conventions that I see here with the SPHN ontology. Click OK. Then I would like to add a comment describing what this node is, or this property is about. So the test object attribute will be containing test object attributes defined by the dataset. So once this is done, we have added the root node for our project-specific object properties that we will define later on. And then the last one to do is for the data properties. So again, expand the root element you had here. You would see all the SPHN attribute data types defined, but we simply want to add now our own test attribute data type to it. So add your name, click OK, and then to this new property, data property that you created, add the annotations, the label, which is test attribute data type, click enter or type enter, or click OK, and add a comment to it. So I'm picking the comment that I have, or the description that I have on the side. Simply click OK, and this is done. Now we can save our ontology so that all the changes that we have done are being kept in memory. So now let's go back to our presentation. We now have the setting for building our project-specific ontology. We have made all the little technical changes, and we can start working with a concrete example. So in this tutorial, we want to add a concept called fluid balance. The information is not in the SPHN dataset yet. So we need to define what is the fluid balance and why do we need it. So the fluid balance in this example gives you information about a sort of input of fluids given to a patient, like an infusion, drinking water could also be an input, considered as an input of fluid, or it is also about loss of fluids, like a urine output. And these two types of information are actually documented in nursing charts and given as information that we can actually use. So what specific information needs to be captured in this case? There are a certain set of guiding principles that the dataset defines that needs to be followed when a concept is being defined. And this is a critical step to ensure that the meaning of the element that we would like to represent is represented correctly and it is processable correctly by any user. So the first thing to do is to separate the elements with individual meanings instead of mixing all those pieces of information. So for example, if you have an input value of 150 milliliter, the SPHN recommends to split it into a value, concept or information, a unit information, and the direction of this information, where here, for instance, it is the input. Then use control vocabularies for value sets, and in order also to fix the meaning of the concepts. So for example, when you have a direction input or output, if you look into the SNOMED CT ontology, you would be able to find some terms or codes that you can refer to, so that fluid output is represented with this code and the fluid intake is represented with this code. So the direction can be defined with one or of these two values. And finally, check if you can reuse existing concepts. A meaning should only be defined once. So in the example of our fluid balance, we may have information about the fluid type identifier, a name for it, and a coding system and version where we found this information. So here you see it's SNOMED CT. But if you look carefully in the SPHN dataset, there is already a concept defined for that, which is the code. So you can simply reuse existing SPHN concept in your project-specific dataset. So these are the three main guiding principles from the dataset to be followed when a new concept is being defined in a project. So the fluid balance here in this example is defined as follows. We have a concept name, fluid balance, which has multiple properties or attributes connected to it. So it has a fluid type, which is of type code and has possible values coming from a SNOMED CT specific branch. You also have a value information, which is a quantitative type of information. There's also a direction, which states that it's either an intake or an output. There's also a start and end time of this recording of the fluid balance. And there is a unit. So the next step would be to update the RDF ontology or schema that we are developing by following the rules and conventions that were provided in the previous slides in order to incorporate the fluid balance and its related property. So we have the concept defined here in a Google Sheet. So we will simply use this one for incorporating the information in Protégé. So the first thing to do is to take this concept and add it as a class in the RDF ontology or the RDF schema that we are developing. So let's switch to our Protégé view. We go to the classes, and this is how we add a new class in our project-specific ontology. You select, or you make sure that you select the test concept class and add a subclass to it. This subclass will be named fluid balance. Again, you have an upper camel case convention. So we have an F uppercase and a B uppercase. Once you have done it, click OK. It's the same as before when you created a test concept. The only thing here is that you have to make sure it goes under the test ontology. Once you have created the fluid balance, you need to add a label, fluid balance, and a comment or a description to it. For the comment, I will switch back to the Excel sheet, and you see that the Excel or the data set should give you the description for your concepts and for your properties or attributes. So we simply take this definition, copy it, and paste it in the comments here. So the fluid balance says that it is either an intake or output of fluid to calculate the fluid balance. Once this is done, click OK, and you have your information annotated to the fluid balance. So now we can go back to our data set and see what other type of information does the dataset provide us about the fluid balance. We have already added the description, and you can see that there is also a meaning binding to a SNOMED CT code, telling you that this code is equivalent to this fluid balance concept. Or in other words, the fluid balance defined in the test ontology has the same meaning as this code or concept in SNOMED CT. So how do we add meaning bindings to SPHN projects? What we have to do here, so we go back to our Protégé ontology, we select the class to which we want to add a meaning binding. We go to this description here, and you can see that there is an equivalent to. Click on the plus sign next to it, and this is where you will be able to add that a fluid balance is equivalent to another class coming from another terminology. How do we do that? Select the class expression editor tab, add an apostrophe to start with, and then type in the label of the equivalent class that you would like to add. So if you remember from the SNOMED CT, it was fluid balance status, and it has some other text next to it. But if you don't know exactly which text it was, you can type tab, and this will autocomplete whatever information that the Protégé tool can find in the different classes that are being loaded in the ontology. So now it does find SNOMED CT information because SNOMED CT has been imported in the SPHN ontology, which was imported in your project ontology. Therefore, the tabulation works here. Otherwise, this will not be doable. So once you have added the class to which you would like to add the equivalence, you simply click OK, and you can see that now the fluid balance is equivalent to the fluid balance status observable entity coming from SNOMED CT. So we have now added a meaning binding to a project-specific ontology class. Now let's go back to our dataset to see what other information we have. So we have selected here the next line because we have added all information provided by the concept. And this line is about the fluid type. So it is a composed of, meaning that it will be a property in RDF. And you can see that the type is code, meaning that we are reusing the concept code coming from the SPHN ontology. And this tells us that the type of our property will be an object property. So now let's go back to our Protégé tool and switch to the Object Property tab. We expand the content that we had here, and we select the test attribute object, which is the root element for any object property that we would like to add for this ontology. What we do next is to add a subproperty to this test attribute, and we need to provide a name to it. So the conventions in SPHN are defined in the documentation, and you can read it thoroughly. But the basic convention is that we start every property with has, followed by the name of the domain, or here it will be the fluid balance. So has fluid balance. And then if the dataset provides a specific naming for the type of elements you're annotating here, you can add it. So it is a fluid type. So it is has fluid balance fluid type. And then you finish with the range if it is one single element. So it is a code. So we know here that this property is about the fluid balance fluid type code. It is the code that we are providing about the fluid type. Once this is done, you click OK, and then again, you do the same routine. You have to create a label, has fluid balance, fluid type code, and we need to add a comment to it. So select annotation, RDF as comment, and we can select the text coming from the description, copy it, and paste it here. Select OK, and you have added your comment. Now we have to go back to our dataset and see what other type of information we have available here. So we have added that the concept is the fluid type, it has a description, and it is of type code, but it's not any code. It is a SNOMED city code that should be provided with the value of the fluid type. And specifically, there is a subset of a SNOMED city code given. So the codes that are provided, or the values that are valid for the fluid type, are any children or any sub-element of the substance of SNOMED city. We go back to Protégé. And here we need to add information about the domain in which this specific property is valid and the ranges in which it is actually valid. So the domain is basically telling you, okay, what is the input that this property can have? We know that it is a fluid balance. So a fluid balance has a fluid type code, a specific fluid type code. So in the domain here, I have to add the fluid balance. So I can either use the class expression editor as we did previously and add the label to the fluid balance defined in our project classes. Or the other option is to go through this class hierarchy. So you can click and select this tab, class hierarchy. This is another option. And then you see that you have all the classes defined in this project that are represented. And we are interested in the fluid balance coming from the test concept. So I can simply expand the classes defined in the test concept, select the fluid balance, click OK, and you can see that for this property has fluid balance fluid type code, the available or possible domains are fluid balance. Similarly with the range, I need to add the annotation to the SNOMED city substance. And if you look into the SPHN concept, scroll down, go to the terminology, you see that there is SNOMED city concepts there. But since SNOMED city is a huge and large semantic representation, we prefer to define our ranges using the class expression editor as we did. So again, we start with an apostrophe. You see that now it is providing you fluid balance status because you already entered it and it kept it into memory. But simply remove it. Start by typing substance, and you can use tab, and you see that there are several options that are provided now, and not only one, because there are several elements that fit with this pattern substance, but we are interested in the substance with the substance into parentheses because this is the code provided by the SNOMED city. This is the label provided for the code substance. So simply select the substance, click OK, and now we have also annotated the range of our fluid balance type. So whenever you are annotating an object property or a data property, make sure to provide the basic annotations, so the label and the comment, but also add the domains and the ranges in which they are actually valid. This helps for the data production side. Okay, so we have done this annotation. We can again go back to our dataset and see that we have fulfilled all the requirements for the fluid type. So we have the description and we have annotated the subset of values under which it is valid. So next we have the value concept, or composed of, which is of type quantitative that we need to annotate, and you can see that there is no other information provided for this composed of. So we simply need to have a data property created, which will be called has fluid balance value, and the description is this one. So I'm copying already the description in memory. I'm going back to Protégé, select data property, expand the tree here, and I select the test attribute data type. I add a subproperty, which will be called has fluid balance value. Click OK. I'm adding an annotation here, so I already have my comment in memory, so I can just copy paste my RDFS comment. I can also add the RDFS label, so has fluid balance value. Click OK. And here in the domain and the ranges, so the domain is still the same. It is the fluid balance that we need to provide. So I can go back to my class hierarchy, test concept, select the fluid balance, click OK. So my domain of has fluid balance value would be fluid balance. And the range here, since it is a quantitative type of element, we use the XSD double, telling us that we can have any value that is of type double. Click OK, and we have our ranges here. I'm just making sure that I can save or keep in memory all my information, so I just save all the content that I have generated so far. So these were the three information that we needed to add for the values. Only that it is a quantitative type of element, the description, and that the fluid balance actually has a value. So the next element is the unit. You can see that the unit has also a description, and it also says that there's only a specific standard that can be used, but there's no specific value set or subset connected to it. So again, I'm copying the description to make it a bit faster. I go back to my ontology, and just keep in mind, since this is of type unit, so we're using an SPHN concept, the property created now will again be an object property. So I go back to my object properties here. I can either select a property from the test attribute objects and make a sibling property to it, or I can select the test attribute and create a subclass. So the name of this property will be has fluid balance unit. Click OK. I am adding the description to it. It's the unit of the amount of fluid intake or output. I'm adding also a human readable label, which states that it has fluid balance unit. And same routine, I need to define the domains and the ranges. So we know that the domains will always be the same here. It is about the fluid balance. So you can simply select the fluid balance. And the range is actually the units concept. So if I'm going back to my class hierarchy, you know that the unit concept is coming from the SPHN ontology. So I go to the SPHN concepts here, scroll down until I can find the unit, and I can simply refer or click this unit and click OK to refer to the SPHN unit. So now if you click into this unit information that you annotated here, it leads you back to the unit defined in the SPHN ontology. So this is how you can reuse existing classes from the SPHN ontology and relate to them in specific properties or classes if you want to add equivalent classes and so on, for example. Okay. So now we can again go back to our Excel and see what are the next steps. So the next step is to add the direction in which the fluid balance is measured. So either it's an intake or an output. So again, I'm copying the description and we see that the direction is of type code, so it will be an object property. And there is a specific value set provided for this property. So it can either take the value of fluid output or fluid intake coming from SNOMED City. So we will see with this example also how we can annotate a range with two possible values or more, but in this case it is two values. So let's go back to Protégé. We are in the correct field, we are in the object properties. I am adding now a sibling class to the fluid balance unit because here I have the fluid balance unit selected. So the property name will be has fluid balance direction code. Click OK, add your annotations. So the label has fluid balance direction code, enter. Add a comment to it. So the comment was quite short here. It says it's either intake or output. Same routine, add the domain. It's still information about the fluid balance. And the range here is a bit more specific. So we go to our class expression editor. We start adding this apostrophe, and you see that it again gives us the last element we annotated with this class expression editor. We remove it. And if you remember, we had in the dataset either fluid output observable entity or fluid intake observable entity as possible values of this property. So how do we annotate that? We again can simply start by adding the fluid intake observable entity, and with the tab I can autocomplete and fill in the annotation. And in order to say that I have two possible values for this specific property, I simply add the OR statement, then a space, and I start another apostrophe to add my second annotation, which is fluid output. And again, I could tap on the tab in order to fill in the term. So with this OR, I am saying here that the possible ranges for the has fluid balance direction code is either fluid intake or fluid output coming from SNOMED City. I can simply click OK, and now you can see how this is layouted. So with that, we have seen now how we can add multiple possibilities in the ranges or in the domain. So this is also something we can have in the domain to annotate multiple values that are possible for either the domain or the range. So now let's go back to our dataset and finish with the last two properties to annotate, which are the start time and the end time. And they are both temporal types of elements or properties, which means that they will be data property in RDF. So I'm taking now the description of the start time. We go back to Protégé. We are going to the data properties. So now we have, we select the fluid balance value, and we can add a sibling property to it, which would be has fluid balance start date time. So we are specifying the date time here because this is the terminology that we are using from the XSD schema, as you will see in a minute. So click OK, add the annotations to it. So I already have the comment. It's the date time at which the input, the fluid intake or output started. And I can add also the label, which just simply has fluid balance start date time. Okay. Then the domain for this one hasn't changed. It is still the fluid balance. And the range, you can see in the built-in data types that we have a date time element that we can refer to. So now we have added the start date time, and we can add similarly the end date time. So has fluid balance end date time. Add the label to it. Okay, and we can also add the comment, so I can copy paste and simply change started by ended because it's the same definition but not quite the same moment. Okay, and then we add the domain, which is the fluid balance, and the range is also a date time. So you can see that the difference in the meaning is actually given to us by the property IRI actually. Okay, so with that, we have now completed our annotation of the fluid balance concept in the project-specific ontology. So now we have some concluding words on this hands-on session where you have learned how to use Protégé in the context of SPHN. So you're now able to load the template ontology provided by DCC and also update the annotations or metadata to fit to your specific project. You have also learned how to add and create classes, object properties, and data properties, and also add specific annotations to them, such as the RDFS label and the RDFS comment. You are also able to refer to existing concepts from the SPHN ontology or also make use of other terminologies like SNOMED-CT and other that are provided in SPHN. You have also learned how to add the meaning binding to your project classes and how you can add multiple domains and ranges to a property. Do not forget to save your work when you are done. And we have also provided a few references here. So you have the SPHN Semantic Framework documentation, which has a section on the ontology generation user guide. So there is a user guide that you can have a look at, which provides more information and also conventions on how to define specific elements in RDF. And we also provide the SPHN ontology and the template ontology in the DCC's Git. Thank you for following this hands-on session, and if you have any question, do not hesitate to contact us at dcc@sib.swiss.